Hello, people from the internet. Here we are again. After posting my tutorial about geometry creation in Vex, a lot of people asked me via the comments and on Vimeo whether the same effect is possible to create inside of Cinema 4D, and I said no, not without plugins, but that's actually not true. I found a way to create something very similar by using an old and unknown feature of thinking particles, and I want to quickly show you how to do this in Cinema 4D with off-the-shelf tools. When working with thinking particles, the first thing we need is an espresso tag to hold the thinking particle nodes. What I usually do is create a null and name it TP, but it really doesn't matter too much. You can put the tag anywhere where you like, and you even can move it later on because everything inside of the espresso environment is just linked from the object manager. So I created this null, and now I bring in my Nymph object. The first thing we want to do is exactly like in Houdini, scatter points on this Nymph. So the first thing is we need points, and these are created with the particle born node. This is the particle generator. And if it's set to count, it generates 100 particles per second, but I want a specified amount of particles every frame, so I set it to shot and put, let's say, 1000 particles here. If I now press play, the node creates a lot of particles, but puts them at the origin, that's why you don't see them. What we want to do now is we want to use these particles to scatter locations on the surface of this object. And that can be done by using the surface position node. The surface position node has no labels on the inputs. That's a specialty with thinking particle nodes and inherited from Sebas when Maxim bought the thinking particles code. So go to ports, show names, and it will happily show the names. Connect the particle output of the generator to this particle input, and that will make this node execute for every particle that comes out of this port. Now we need an object port to specify which object to use to sample the positions from, and create an object port on the Nymph link object node and connect it. Now this surface position node is sampling positions, and they come out of this port, but they are not used by the particles yet because we have to tell the particles that they should use these positions. That can be done by a set data node. So create quickly a set data node, connect the particle input because this node too has to know which particles to run over, and then create a position channel. This will set the position attribute of the particles, and we set this position to the position sampled. If we now rewind in time, you see a lot of particles are created here on the surface of the Nymph. Let me go to the thinking particle settings and switch this to ticks, because then you can see it better. Great, now we have positions. The next step is that we want to find the closest particles around every particle and connect them with lines. The problem we have with this setup so far is that the particle born node is creating a 1000 particles every frame. So if I press play, you see that the particles are accumulating. I don't want that. I want 1000 points. So we have to somehow make the particle born node stop emitting particles. That can be done by a time node. Time. This time node outputs the time in seconds, but just delete this port and create a frame port instead, and it will output frames as integer numbers. And now we use a compare node, and this compare node will compare two values. So we compare the frame to, we use a equal function, and we compare the frame to, let's say, 0, and create a on port on the particle born node connected to the output of this compare node. This node here compares the frame to the second value, which is 0, and whenever this is true, it outputs on 1, otherwise it outputs a 0. And that makes the particle born node work only on frame 0. And as you can see, if I press play now, we have one set of particles, and that's it. After creating these, the particle born node will stop. The next thing we have to do is we have to put all these particles in a group. Because thinking particles works like this. All the particles that are created end up in a global particle array, and there is only one of these arrays per scene. To use these particles later, we want to put them in groups to divide this array up in different parts. So create a particle group node and make sure to use the first one. This one is used to set the group. I have already groups here in this scene, so drag over group A to this group node and connect it to the particle birth. Now this group node will fire for every particle and put it in the group A. If we now rewind, you see that you see nothing, and this is because use color is ticked off. If I tick it on, it will inherit the color of the group, and you see all the particles are red now. Everything is in group A. This is the particle creation. The next step will be finding the closest neighbors. And that can be done, and this is a whole trick by this technique, with the particle path AB node. What this does is it reads this global particle array and outputs all the particles it finds, but it does so not only for one particle group, but for two particle groups. So basically, the normal particle path node just outputs the particles one after the other. So basically, the whole Espresso tag is working like a for loop. With this node in here, you have two nested for loops. So for every particle that comes out of the first port, all the particles of the second group are output. And this enables you to create relationships between particles. In our case, we want to search for every particle all the neighbors of the same particle group. So what we do is we link up group A to be group A and group B to be group A2. Now, for every particle, all the particles of group A come out of port 2. And the most important function of this node is that there is this drop-down called distant type. And what you can do with this is you can set it to inside, and that means that it will only output particles at the second port that are inside of a radius of, in this case, 10 units around the point that comes out of the port 1. And this is exactly what we need, because now we can find all the particles that are inside of a specified radius around the search particle. What's interesting to us to be able to create lines between the particles is the particle's position. So the next thing we want to do is fetch a particle get data node and connect it to port A, and copy and paste it and connect it to port B. And we create the position channel as an output on both nodes. Now we have the position of particle A, and for every particle that comes out of port A, the position of all the particles inside the search distance that come out of port B. So we have two positions, like we had in Houdini, and we can use these to create geometry. Unfortunately, Espresso is not capable of creating geometry directly. So at this point, we have to switch to Python. Fortunately, there is a Python node, and this Python node is happily able to create geometry directly inside of Espresso, but you have to pass the data to Python. So the first thing we want to do is get rid of all the standard ports. We don't need them, and create our own ports. The first one is a vector because it's used to bring in the first position. Let's create it, let's rename it to pos1. Then we need another vector, rename it to pos2, you guessed it, and connect these two positions. Now we have the two positions inside of Python, and this Python node will execute for every particle that comes out of A and then for every particle that comes out of B. So it will really go through all the particle connections that are possible. But we are not done yet. What we need is we need an object to store all the geometry we are creating. So let's create a second null object and name it geo. You can name it whatever you want, but I name it geo because it's descriptive. And let's create a link port here on this Python node called geo. And with an object port on the geo node, we can link it up and make this information available to Python. Now the Python node knows 2 positions, and it knows this null. That means now we can go into Python and start to create the geometry. We click here on the Open Python Editor button, and this brings up this code editor where we can start to write Python. The first 2 lines inside of the main function are reading global output 1, and output 1 is pos 1 plus pos 2. This is not very useful. Let's get rid of it. It's there as a default thing because this Python node used to have an output port, but we don't need it. The first thing we need is we have to make sure that this node does not execute over and over again, because when we press play, this will execute in every frame and will create the lines in every frame again and again, same as before with the born node. So what we want is that this only executes once, and once it has created the lines, it should stop. But we do not want to have the Python execute in frame 0, because frame 0 needs a lot of time to create the particles, and it just works better if we just go to frame 1 and create the geometry on frame 1. So the first thing I want to do here is to limit everything inside of the main function to only happen on frame 1. And I can do this by writing an if statement. So if frame is 1 and a colon, this will make everything after that execute only if the frame is 1. The problem is we don't have a frame variable inside of Python here. We can, of course, use a Python function to get the frame variable, but it's easier inside of the Espresso interface to just create another port of type integer, rename it to frame, and this will make this variable available. Then we can just duplicate this node and connect it here, and it will output the frame into Python. Now we have the frame. In our case, we want to create a spline, a linear spline, for every single connection we find here with a path AB node. So let's switch to the Cinema4D Python documentation. And let's look up spline object. Here you get a list, and this very first one is a spline object. Here is a spline object, and this very first function, the spline object init function, is what is used to create a spline object. So the spline object function wants a point count, so how many points should the spline have, and a type. And the list of possible types is down here. These are basically the interpolation types you know from Cinema4D. And what we want to do is we want to use the spline type linear. So go back to Cinema4D and just create a variable called spline to hold the result of this operation, and then we write spline object, give it a point count, in our case 2, because every connection will have 2 points, and a constant that's telling the program which type of spline to create, in this case a linear spline. So now we have a linear spline object, but we don't have any points specified yet. This is very similar to the Houdini thing, where you have an empty polygon, so basically connectivity information, but you have no points until you specify them. And this is exactly what we have to do here in Cinema4D. We have to specify the points. We have multiple possibilities to do so. One is to set the points one by one. Another possibility is to just set the whole point array, so all the points that have to be in the spline at once. And as this is a little bit faster, I will do this. So create first an empty array called points. This is done by assigning an empty array to this variable, and then we can just put points in this array. And we are using the append function to append points to the array. So let's first append the first point, the first position. That is points append, and then pos1. This is how we called the variable for the first position here on the Python node. And then just copy this and paste it. And let's append position 2. So after these two steps, we have an array holding the two positions we want to connect. And we have already a spline object. So what we can do now is we can set the points to be used by the spline object. And this is done by spline set all points, and then passing on the array with all the points. In our case, this is called points. Now we have a spline and we set the points. So there is a spline with actual geometry, but it only lives in memory. It is not in the Cinema 4D scene yet. What we have to do to show this object is we have to put it into the scene, and there are functions for this. So let's switch to the Python documentation again and search for insert under. And it will find the GE list node insert under function. And here you can see this function is applied on a Cinema 4D object, and you have to pass on the object that this object has to be inserted under as a child. So let's do this. In our case, what we want to do is we want to insert the spline as a child object of the geo we created earlier. So let's say spline insert under geo. Now Cinema 4D will put the spline into the scene and it will start to display it. And as this node is executing for all the connections, it will create a lot of splines and put them all under this geo. So basically we are done. There is just one thing missing. We have to notify Cinema 4D about this change, because as soon as you are inserting geometry into a scene, you have to fire an so-called event to tell Cinema 4D that it should update all the managers and should notify all the parts of the program that the geometry has changed. And this is done by an event function that is called C4D event add. That's it. So now, if we did everything correctly, the setup will generate all the connections in frame 1 and put them under the geo node. So let's test it. Let's rewind the time and press play, and oh no, you see a lot of errors displayed in the console. This is telling us that the spline object is not recognized, its function isn't recognized, because we forgot to put a C4D prefix in front of this function to tell Python where to look for this function in the C4D module. This is what we had to do. So next test. And it worked. Look at this. You have some splines here. And it actually created spline connections. And instead of this geo node, we now have a lot of splines that are connecting the points. Maybe the search radius of 10 is a little bit small. Let's make it bigger. Go to the ppath node and up this to, say, 40. We can close the code editor for now. Unfortunately, you have to get rid of the result of the previous execution by hand. So middle click on the geo node. With Control, you can deactivate the geo node itself and delete everything from it. And let's try this again. Now it needs more time. And if I switch back to the big viewport and quickly hide the object, look what happened. It actually created all the connections here inside of this geo node as splines. So basically it's working and it's doing the same thing as in Houdini. The only problem with this is you see it by if you're observing my laggy viewport, that this is not very fast. This is due to the fact that I created a lot of objects. I created 5,000 splines. So to speed things up, select all of these splines by the same technique, middle click, and then with Control deactivate the top node. And let's choose Mesh, Commands, No Conversion, Connect Objects, and Delete. This will take some time. But once it's finished, you have one spline object that is far more efficient for display and handling. You see now the viewport is very fast again. Don't forget to disable the Espresso tag now, because otherwise every time you rewind it will start to generate the connections again. And now let's add some actual 3D geometry to these splines. For this I create a circle. Let me directly go in, set it to uniform and only one subdivision point. Make it small. Create a sweep. Put the circle in. I recommend to deactivate the caps because they just need time and they are not needed for this, and then drop in the spline and it will happily generate renderable geometry from our spline connections. So there you have it. It's perfectly possible to create this plexus style effect inside of Cinema 4D without plugins and with just off-the-shelf tools. I hope you enjoyed this tutorial. I was very excited that this is actually possible inside of Cinema 4D. If you have a better idea how to generate this in Cinema without any plugins, please let me know. And see you next time.